So welcome you all. So I will show you the question on the screen. Try to mentally calculate, find out what is the output, and then maybe we'll give 5 minutes for every question. Or if it is very simple, we'll go forward fast. Or if it takes more time, we can spend more time. There is no hard and fast rule. There is no evaluation. There is just free format. Anybody can give any answer. There is no evaluation component. Just enjoy just doing some C programming quizzes. Okay, it is like a quiz. Okay. What we will do, we will solve it immediately, so that what we learn from that will be useful for the next question, so that you can still keep applying that as we go forward. Don't give up on anything, even if your first few answers are wrong. Just keep trying. Even if you don't know much of C program, try to make an attempt. I'm sure at the end of this session, you will have confidence that you can do some, a very good C programming skills you would have picked up. Okay, so that's my goal. And I have also shown written the program on an IDE. We can run it also later on. But let us first see one by one without running any of them questions. Okay. Before I start, any suggestions, anything you guys want to share? Is it okay, the format, or do you want me to change anything? Okay, we'll see as we proceed. If you find that something can be done differently, please feel free to tell me. You can also, I will keep the chat box available. What you can do is you can keep posting your answers. I won't tell whether it is right or wrong because it will influence others. Independently, you can work on, and if you get the answers, you can just type it. Don't give any reasons why you think your answer is correct or wrong, but just you can keep giving your answers if you solve it. But I will give time for everyone to solve, and then we will discuss. Okay, fine. That's game rules of the game. So let us start with the first question. Okay, let me expand it. I hope you have read the rules already. So I want you to tell me if this function is run, okay, along with these declarations, what will it output? One thing is this program is correct. There is no syntactic error. It will compile properly. Okay, so you don't need to worry about that. So let us start now. Okay, more or less we have. Oh, sorry, I removed the. Okay, let me do one thing. 1 second, hold on. Sorry for, so that I don't need to take it out. Okay, now things are better. Okay, very good. Let me now, we'll solve it together, okay? I will not comment on anything which is correct, which is wrong. Okay. So, just for the benefit of everyone, I will give the background little bit, even if it is, you are knowing it, please bear with me. Where am I? Where am I? I am not there anywhere. Okay. Okay, guys. Okay, done. Now, this whatever is static, we are defining it as the name says is global, and it being in the global area, it's not inside the function, it's in the global memory. Okay, so just to tell you something about static variables, what happens with the program is when we are building a program, the memory of the program, what is needed, is split into multiple things. One is code, other one is data, and then stack. Now the stack area is based on where the stack pointer is at that moment. Okay, in the sense, suppose your program is running as a part of a process P1, and its SP is pointing at some 100 address stack pointer, the register of the CPU, then your stack will be at 100. And then if suppose some other process comes up and it has got its status context saved, and then it is address is some 200, its stack will be at 200. Now you have other thing also. Normally what happens, because paging is what is followed everywhere, so pages are there. So code will be in some page, data will be in some other different pages, and stack will be on different pages. The reason being, code is only read only, and data partly, maybe if it is initialized data, and then if it is a constant, it will be only read only. Some other data will be a read write, and stack is always read write. Remember, stack access permissions are always read write. Now different pages may be there. Now what is our pages? The pages are, if I explain about the virtual memory, we have the program's process 1 has some data code and all that, which are all specific to some locations. Okay, maybe it is starting with some 20,000, and then the addresses go like this, and they may be arranged one after the other, or maybe some gaps may be there, code, data segments, and all those things. I will not use segments, I will use pages. Whereas this is a virtual address, virtual memory, virtual addresses. The process looks at its own virtual address. Okay, and whatever pointers you see, they all actually give you the virtual addresses of where the program is thinking it is lying. Okay, but MMU comes into play in between, memory management unit, and then finally DRAM, which is having the memory, wherein these pages are mapped onto, which is the physical memory. Now this address will be different, because every address that process is giving out is translated in real time by the MMU hardware, and then it is accessed on the real memory. So whatever pointers, what you see, suppose character pointers, its address, whatever you see, it's a virtual address of that process. Whereas actually where it is residing in the memory could be different based on the mapping between that particular process virtual address to the physical memory. It could be something which need not be contiguous. Let me give an example. Suppose you have a stack space which is going into some 8 kilobyte of data, or maybe 16 kilobyte of area, your stack. Okay, and then suppose your paging size is 4 kilobytes. You know that stack is always contiguous spaces. Stack will be always contiguous. So 4 kilobyte of stack in the virtual space, another 4 kilobyte of stack, they're all together 8 kilobyte in terms of virtual memory. Whereas if suppose you have DRAM which is split into 4 kilobyte pages, suppose these two pages cannot reside on the same contiguous space in the physical memory. It could be on two different locations, totally different. One could be here, one could be top, or need not be in the increasing address or decreasing address. So when the transition happens from here to here, the virtual addresses will be contiguous, but MMU will translate it to different locations on the physical memory. So that is also possible. You can imagine that all these addresses, what you see is the virtual memory addresses, and what is really where the memories are, actual contents are in the physical memory, or may not be same, and it will be different, and it will not be contiguous. So this thing you should keep in mind when we are dealing with pointers. Okay, so any doubts you can always, because I am not keeping the thing chat online, so you can talk, then I will stop. Okay, now let us come back here. Assume that we are having some memories, and these are the different memories that are needed. Let us come to the program now. Okay, now this program has global memory. This basically, it is the static variables are in the global data memory. It is not in stack. When I say global, means it is a data memory, and is it the read write? Yes, read write, because there is no const here. If I had put const here, then that would have been in a read-only data memory. Okay, so you can imagine that where they will be residing. Now, who is doing it? It is all done by the tools. Basically, the loader takes care of loading it, and linker, after merging all the modules of your programs, it will look out all the variables that you have in your program and then groups them all in together and then puts it into proper areas, read only or read, read write or whatever. So now S global is 100, which is there in that area. Now I have a pointer which is initialized to this variable. Okay, so this is an int star pointer. This is also integer variable. So I am sure you are aware of it. Now, one more thing you should keep in mind, that the static variables are initialized when the program is loaded. Okay, when the program is loaded, it is already done by the tool. Okay, initialization is not done during the execution. Remember, that is why you cannot put any executable instructions here on the right side of the assignment to static variable. If you say that another variable I and then I into 2 equal to S global static, it will give error because it cannot resolve it. It cannot perform any instructions are not executed for initializing the static variables. It should have been computed without executing anything. It could be some constants. You can have some constants and then pi into 2. You can do that. All that are done by the tool. It's not done during the execution. So anyway, some memory in the read-write memory, data memory, this 100 is residing. And then the pointer variable is also located here, and then it points to that variable, which is a virtual address, as I mentioned. Now let us go into this. What happens to the static variables which are inside the methods or functions? This slocal also, for all purpose, it could be residing just adjacent to the S global variable. Remember, it could be residing just adjacent to each other, because the same tool is allocating the variables locations. But the access permission or the visibility or the scope of the variables are different. You cannot access slocal from anywhere, though it is also residing just adjacent to the global variable. So why am I saying it is in the data area? Because it cannot be in the stack because it is initialized and it should be preserved across multiple runs. So they will be also in the data area somewhere. Now we have some slocal 200. Now what I do, address of slocal I take, assign it to the some integer pointer. Now where is this residing? This IPS local is a local variable. So this pointer itself is in the stack. This pointer itself is in the stack, but it is pointing to some variable which is in the global area, having a scope only within the function. So all this you should remember it. So this resides in this variable itself is residing in the stack. If you get the address of this and if you take the address of slocal, they will be totally different. You can see that they are on two different memory segments. Okay, fine. Now what I am doing,
hello.
Of this into IPS local variable.
Hello.
Now what I do, content of this int star. That means I am actually getting the address of slocal into content of the global pointer. Okay. Earlier, the global pointer was pointing at this global variable address of this 100. Now it has been replaced with the address of where this slocal is residing in the global area. So that address is gone after this initialization. Okay, we are replacing the pointer is now, instead of pointing to the S global, it is going to point to the S local now. So this is done. Star of that is done. The star of pointers, that means addresses are getting exchanged. And then what we do, IPS global is equal to IPS local. Then what I do, the address, actually this is also, sorry, what did I do? Okay, star of IPS local is the content. Okay, sorry, I mistook it. Am I right? Yeah, star of IPS local is the content where this IPS local is pointing at. Okay, it's true. Address only is getting exchanged. No problem. Now what we do, we are at star of that, we are incrementing it. Now plus, you know that it is equal to a plus 1. So star of this, which is star of that means you are accessing the, both are now pointing to the same variable 200. So 200 plus 1, 201, and 201 plus 1, 202. So the output is 202. Okay. So most of you have got it right, I think. Some of you exchanged some answers, confused a little bit. Okay. Any questions on this so far? You can also try it out. I will give you the program and then play it around later on. Now,
hello.
Can we move forward?
Hello. Hello. Hello.
Wait, no reply.
Hello.
Yes or no, I don't know. Are you all there?
Hello. Hello.
Hello, sir.
Sir, am I
Oh,
audible?
sorry, I'm not able to hear you. Somebody is speaking.
Hello.
Yeah, please go ahead.
So can you hear me?
Yeah.
Sir, the first question is, why is pointer residing in the stack? Because pointer is also an integer variable, so it has. So I'm just confused. Why pointer has to be in the stack?
Okay, it's Sandeep. Okay, fine. Let me explain. Okay, you can go on mute. Okay. Now, the question is, maybe if others have not heard, why should this IPS local variable int star variable, why should it be in stack? Okay. Now, you know that when there is a function, and then when we are declaring some variables inside them, it doesn't matter whether you are declaring int I, int star IP, or float f. These variables, unless you have a storage class saying it is static, okay, if you don't give static, they are non-static or local variables. Okay, it doesn't matter whether it is holding an address or a value or whatever. First thing. So let me clarify one more thing. Int I is there, int star IP is there. Now, you know CPUs have registers, right? Now let us assume we are registers. We are assuming a 64-bit register because we are running it on a Intel iCore 7. So it is having a 64-bit wide registers, R0, R1, whatever. Okay. No, sorry. Intel processors have EAX, okay, EBX registers. Okay, R1, R0 or ARM processor. So I will call them as EAX or EBX. I'm using E because it is a extended registers, so 64-bit registers. Now, there are many registers in the processor, and these variables, if they have to be manipulated, suppose if I say I++, they need to come to the register to get manipulated. Okay, in the sense, increment instruction has to be done, increment EAX has to be done. That will be done by the ALU. For that, the variable I, it has to be incremented, means it should come to the register and then get incremented. Suppose this is the AX register, EAX. Okay, EAX means this is 32-bit, this is 32-bit. Okay, lower 32-bit. Now, one more thing you should keep in mind, whether I am building this tool, this application in a 32-bit mode or 64-bit mode. Okay, I may be doing it in 32-bit mode or 64-bit mode. So what I mean by that, the processor, whatever I am running this process on, could be a 64-bit CPU, but what I have built is a process which is a 32-bit process. Okay, that means its virtual address range is only 4 GB. That means 2 power 32. All its addresses are only 4-bit wide. Okay, 4 bytes wide or 32 bits wide. Addresses are 32-bit. Registers integers. If I have an integer I, it will be of 32-bit. If I have a long, then it's 64-bit. So all those things are there. That means either you have a okay. Let me come back. Let us assume that I am doing it in a 32-bit process. I am using 32-bit tools. The GCC tool I am using 32-bit. So this is going to be a 32-bit process. That means all my integers and pointers are all going to be 32-bit wide. In that case, okay, I lost my face. Okay, in that case, we have to assume that we are not going to use all the 64-bit wide registers of the CPU. Only the lower 32 bits are going to be used. Okay, this is not used when you are running a 32-bit process. It's not that one 32-bit process is running on this part of the register and then another 32-bit process is running on the higher end of it. It's not possible because it is addressed as EAX. Either the instructions could use all of them or only the lower part of it. Okay, so now let us come back to your answer question. Whether you are having I will also be residing in a register, whether IP, integer, pointer, that will also be residing in a register. It could be some other register, maybe base pointer or whatever, or it could be some BX also. We don't know. It depends on the tool, compiler tool, what register they have used. The thing is, the I variable may have some value that you are stored. 10 will be there in the register. Whereas if your pointer is a 32-bit pointer, its address will be here, maybe 20,000 or whatever will be here in the register. Now coming back to your question, now all of them are to be in the register, but since the variable int I, int IP are local variables, they need to be allocated in the stack. There is no other go. It doesn't matter whether it is a pointer or an integer or a float or whatever, they will be on the stack. Now, when I mean what I mean by the stack is there is a stack pointer, maybe ESP, enhanced extended stack pointer, which will be pointing at some address where the stack area is reserved. It is on the virtual space here, but MMU will take care of converting it as I explained to you in the physical memory. Now, it will be residing in the stack. When I say some variable is residing, it is allocating it on the stack by moving from one place to the other. Okay, stack pointer is adjusted and then IP will be allocated. So when I have a declaration like this, the compiler takes care of allocating different parts in the stack, different variables, and then says that this is the stack frame which is going to be used by the function. So when this question1 function is entered, when it enters there, the execution comes here, it allocates a space for all the local variables. Since IPS local is a local variable, not because of the name, but there is no static keyword, it will be in the local memory. Whereas this local, this variable, I named it as local to confuse you. It is local in terms of scope, but it is actually in terms of memory, it will be in the global area. Okay. So to answer your question, this will also be in the stack area. It doesn't matter whether it's a pointer or a integer. Is it clear or you have some more question?
Yes, sir.
Okay,
So
can you run this program? Okay, the problem is it will output all the things. Okay, let me do something. Okay, so you will not be able to see the output of others. Let me build it. Okay, run it. Oh, sorry. Okay, so let me show the code. I'm sorry. Let me. Okay, this is the code. And I am running. Okay, let me show you what I am doing. Just I put all the include and then all the prototypes I have defined so that I don't want the compiler to crib what is the prototype of those functions. Okay, and then I am calling one by one. I have put the global declarations and then if I wanted to, okay, I told you that these locations will be different, right? So let us see that. Okay, printf. address of IPS local is okay. Address of S local. Okay. I hope you are clear, right? I am trying to get the address of where this variable is and where this variable is, which is static, and this is a non-static or local variable. So let us try to see the addresses of them. I am printing it as P pointer so that it prints the address. Where is it? Okay, it's running now. So let me close it. Okay, see here, IPS local is at some 61 FEEC, whereas S local is at 40500H. So you can see that they're all of different segments. Okay, the address of the higher word, this higher word is different. Okay, let us see. I said that S global and S local may be residing one by side. So let us verify that also. Okay. So where is it? I will print S global also. I can access it because I have a scope here because we are doing it already. So let me write it. Yes. Okay. Are you clear? S global. I am getting the address of this guy after getting the addresses of this. Okay. So we are trying to see what is the addresses of each of those variables. Okay. Build, rebuild. Okay, done. Okay. See here, S local and S global, as I told you, they are just residing one behind the other. Okay. S local is later, S global is in the, no, its address is lower address compared to this address. Why is it so? The compiler, okay, while seeing this, it saw that, oh, there is a static variable which needs to be part of the global area. So it has seen it in this order. So yes, global, it has allocated. Allocation is not one of the compiler. Okay, please don't get confused. Compiler only understands the code and then groups the variables and puts the labels of them and creates a list of variables which are to be located in some global area. Okay, and then linker groups them, and linker or locator, whatever, they actually finally give the memory address where it is supposed to be. Okay, so you can see that both of them are just adjacent to each other in terms of memory. In fact, you can do something. Okay, I will tell you, once you know the address, you can actually access the variable using this pointer. I can access the other variable. Okay, from somewhere I can access this S local from somewhere else, unless nobody can catch it. Okay, how do I do it? Okay, let me do that. Okay, see this question, S local is somewhere, right? Can I access it here? Okay, after the initialization, after question one I come out, I want to access it. Okay, let us see whether it allows. Okay, printf, I want to access because I know the address. So question one, trying to access S local. Okay, what is the name of that? S local. Okay, outside function. Okay, so %d, I want to /n, comma. Now I want to access it. How do I do it? So I hope in the next run also the relative position will not change. I want to access S local, but I have the address of S global only with me. How much I should decrement it by 8? Okay, 4 minus 4. This is 12. Sorry, I have to add it by 8. 12. It is C is 12. So from the S global address, I have to add plus 12 to get the address of that. So let us do that. Okay, I am accessing it. Star address is what? Ampersand. Where is it? Ampersand of S global. Okay, where is S global? I can access it. Oh, okay. It is in the global state. Okay, S global plus 12. Oh, okay. Pointer I am taking, and then I have to do plus 12. I'm getting the address, dereference it, and print it here. Let us see first of all it compiles or not. Okay, okay. Some questions came. Okay, nothing. Okay, fine. Let me build it now. I will explain to you in case if you're not understood it, whether it is proper or not, we'll see. Does it allow undeclared? Okay. What I will do, we will move this, okay? Doesn't matter. I will move it. Okay. Rebuild it. Done. Okay. Now let us see. It is accessing 214 outside a function 214. Is it correct? 200 plus is correct. Why is it 214? Okay, let us change this to 300 and see whether it is.
Memory address is in
First of all, 314 it becomes. Then we will try to understand it.
Sir, 12 is getting added to 202.
Yes, 314. Now, why is it so? Did I change anything there? We have to see.
Sir, I guess you have to put the.
We increased it to how much we increased it? We ran it once only. Oh, it is printing address, is it? No. How do you say? Plus 12. I didn't get you. Printing sum after taking value from address, getting values of S global and adding 12 to it. Oh, yeah, it is. We are adding the address, is it? Oh, yeah. I have to put a bracket. You are right. Oh, no. I am trying to access. Okay, wait a minute. One more bracket, maybe it will solve it. I think I'll see. Or am I doing something? Let me see. Okay. Oh, one more bracket to print. Okay, I don't know whether bracket will solve the problem. Okay, ampersand pointer plus 12. Oh, I didn't do that here. Okay. The problem I'll tell you, if you do that, it will do, I should not do 12, okay? Because it will advance. Pointer arithmetic is always, it takes the scalar value of that. When you say ampersand of S global, it is an integer pointer, so it will add 4. So you have to actually add plus 2 only you should do, because it is the gap is only 4 plus 12. So I should do only plus 2, okay? And then it should work. Okay, let me just show you. First I will clear myself and then I will explain you. You can also tell me what is that. Okay, plus 3 I should have, plus 3, yeah? Okay, let me see. Plus 2 or 3? From 4, 8, 12. Plus 2 only, no? Oh, okay. 4 plus 8, 8 plus 4, No, when you do plus 2, it is two scalar values of 4 will be added. Okay. Pointer arithmetic is always with the scalar value. Okay, just wait a minute. Let us just resolve it. You can try it out later also. Okay, instead of wasting 300. Okay, we have to look at the memory and then check it. Okay. Where is it accessing? We have to check that. Now, why is it getting 300? Ah, correct. It is correct now. Oh, no, it is not correct. Wait a minute. We are printing SP local here, 202. So, okay, guys. I will also try it out separately because we are doing it online. You know, I'm also not able to not think peacefully. Okay, you are saying 3 plus 3. Okay, let me try plus 3, but I feel that is not the right thing. Okay, we'll not do now. Okay, we will do. You can try it out. Okay. Yeah. See, I will tell you what is. Maybe you guys are telling me what is. Okay, let me explain. See, what we are trying to do. We have a global memory. Okay, global memory. We have it in 4 address sum 4. We have this S local variable. No, S global variable. And then at 8. Okay, now. Oh. It is because of even the 64-bit and 32-bit conversion. There will be +1 also might work actually. We have to actually look at the memory and then do it. I don't want to do now. Debug it and then we can check it where the variables are. Okay. We found the addresses anyway. Let me see. 5004 and C. It could be the next location also. Okay, if it is allocating 64-bit for every locations, then the next variable will be +1 only. Okay. It is not +3 for sure because from 4 +1 will take you here, +2 will take you to C. Okay, 8 plus 4, 12. So this is the place where this variable will be. Okay, so let us do it later on. Okay, maybe in the next lab we can do it more. Okay, I will go to the next question. Unless you have any questions now, I will leave it like this. You can try it out. After I give the program to you. Any questions? Because I don't want to delay other things, because I hope you got the hang of it, but we are doing something wrong. It needs some peaceful thinking while doing it. So I don't want to do it in front of all of you making you to wait. Okay. Any questions so far? Is what the observation we have to analyze further. Okay, fine. Let us now go to the next question. Please try this out. Okay. Yes. Assume that somebody is calling it. Okay. Okay, let me give a clue. Okay. The first values, whatever you are given, okay. Still, so far, nobody has given the right answer. Okay. Let me tell you that much. So far, no right answers. Please think again. Very subtle meaning is there. Subtle thing is there. Carefully watch what is getting assigned. Okay, very good. Okay, very nice. It has got many things built into it. I'll tell you where this questions I did. I gave this question to the IIIT Bangalore students, when I was handling ATA's course for them, some of the questions, and then I added some more for you guys now. Okay, so good. Now, finally, we got the answer. It is tricky, okay? But you guys are really thinking a lot, doing good. So let me tell you, static variables are initialized with a 0. All entries, okay? All entries are initialized with a 0 if it is not done by the programmer. So I have declared this array, so not an array structure, and I said it is static and it is in the global area. It doesn't matter whether it is a global area or local area. Now you guys know that the memory for static variables are allocated before the program starts. So now what happens to this is we have this already f is initialized to all zeros, okay? All zeros. It's not 0.0. No. Actually, it will I think it will do 0.0. Okay. Whatever is the format of IEEE 0.0, it will be loaded. Okay. Wait. Let me think. I don't think it will do unless you do f equal to 0.0. It depends on the compiler. Okay. It again depends on the tool. It could be just all 0 entries, or it could be 0.0, whatever is the. Actually, it is also same. I think if I remember, IEEE 754 format, 0.0 also all zeros. I think because sign bit is 1 plus, so it will be all zeros. Okay, fine, no problem. Now, what happens to the C4 character array? C4 is having 4 locations. Okay, 4 locations are there. They are all filled with zeros. In the sense, each byte is filled with 0, 0. Okay, if I write it in a hexadecimal format. Okay, this is 0, 1, 2, 3. Now, what am I doing in the initialization in the function? I am initializing this f with some value 123.4, and then 0th location I am filling it with character A, and then 1. The next location I am character ASCII of character B. I am skipping this second location. Skipping means I am not disturbing it. That means it is filled with 0 already, which is not disturbed. Then this I am filling it with a C. Now let us come here. What is the printf getting in? It is taking 2 things, 2 values, fc1.f. So what is happening? The 123.4, whatever the value is taken from the structure and passed into the stack. Okay, it is passed into the stack. It is stored in the stack 123.4.4. It is not address. The actual value is 14 point content is loaded into the stack. Now, what is passed? Now, in which order it is passed? Please remember a function parameters a, b, c in C. That means in C programming. Okay, Pascal does it in a different way. Pascal does it from left to right. Parameters are pushed into the stack, whereas in C program it is this is the right side. Okay, right to left. Okay, right to left is the parameters passed into the stack. That means if suppose stack is growing, this is a higher address, this is a lower address. Stack is growing towards the lower address, then C is pushed into the stack, then B is pushed, then A is pushed. That is the order it is pushed. Now, what does the printf do? Printf is having, I will talk about printf later on, how it is processing the multi-variable parameters and all that we'll see later. Now, it is getting 2 parameters at least. Okay, FC1 is 123.4 somewhere. It is in the value is pushed, and then address of fc1.c of 0. So fc1.c of 0 is one particular element, the first element of the array C, and then I'm taking the address. That means where the array is starting, wherever the array, this array is starting somewhere, that address is passed. Okay, this address is passed to the printf function. Now printf, what is it doing? Address is here, some address. it doesn't know what is coming in. Okay, it doesn't know what is coming in unless it sees the, what is this called? I forget the name of this percentage F and percentage S. Okay, identifiers or something called. Okay, when it sees this percentage F, it knows that after the format string, this is the format string. What are the parameters are there? It doesn't know how many parameters are there, but it knows in which order it is pushed. So when it encounters this percentage F, it knows that in this location I am having a float value. So it will interpret this as a float value and then print it. And then when it encounters a percentage yes, it knows that it is an address of a string which is passed to the function. So it knows that an address is passed. And then it is trying to print a string. So address is passed. It starts from the address and starts printing everything that it encounters till null. Okay, till it encounters a null, which is nothing but a 0, it starts printing. Now in our case, we have A, B, 0 and C. So the printf will come here and then it will think that, oh, the string has stopped here. So it will only print AB. It will not even see anything beyond that. It will not cross the 0 and then try to explore it. Okay, if it does it, then there will be a crash in the program. So printf percentage string, any string printing is normally done till it encounters a null. Okay, null is nothing but a 0 character, 0 value. So that's why you get AB as the output. Okay, so because you guys want me to print it, run it, so let us run the code. I hope this is clear now. Build. So you can see AB stops there and then F is there. Okay, fine. Any questions on this, guys, before we go to next question? I think we thought a lot about it, so my explanation would have been sufficient now for you. So let us start with the next question. Unless you have some doubts, you can ask always. Okay. I have to make it small. I don't know whether you can view it. Too long. Okay, I will do one thing. Sorry, it is too long. So I will show it here. Okay. S3C is not visible. Why? Everything is visible. Okay, maybe old. There is a read view. Can you guys tell me where is that? Okay, I did that, but you will lose other. Okay, I hope this is clear to you, no? Instar IP, CP. Okay, because this is also visible for you. Okay, I will do one thing. I will show you the code, and then this I will show it here. Yeah, that is better. Okay. Oh, sorry, yes. Very good. But order is different little bit. Maybe this order looks, Anant Jain order looks different. Yeah. Okay. I think, yeah, I can declare that this is the right answer. Shubham, whatever, all these four, Sandeep, Anant Jain, Shubham. Okay. You, all of you reply, then we'll see. Anybody else having different? Okay, most of you got it, maybe. Shall I explain to save time? Okay, so it's not very difficult, I think so, but it is little confusing with so many assignments and all that. So what is happening? We have, what is this? I have all the integer. Okay, one thing I wanted to bring out things are, okay, what I want to bring here is about the void star. Okay, void star. Suppose I have void star VP. What happens is it's a pointer and it is supposed to be holding an address. But when I do VP++, what happens? So suppose you have an array of void star. Okay, suppose you have some void star elements, or void array of void elements. Then void star is a pointer which is pointing to the array of that kind of element. Now, what is int star? Int star is a pointer which is pointing to an array of integer. Okay, I can, if I suppose I have a pointer IP, I assume that it is a 4-byte values. Then when I say IP plus plus, it is incremented by 4. If it integer is 4, it will be incremented by 4 to make it point to the next location in the array, integer array. Now, what happens to character pointer? You know that it will be incremented by +1 because next character will be accessed. This value, whatever we are incrementing it with, is the scalar value of pointers, scalar values of pointers. Now, what is specific about void? Now, when I increment void star, what happens? It actually void doesn't have any, you cannot declare a variable called void. Okay, void v you cannot declare. Void is to say that there is nothing, like a function returning nothing is called void. Nothing is getting passed is a void, so you cannot declare a variable called void. But void star you are allowed to do because the pointer which is pointing to some data type, which could be anything. Okay, a void star pointer could be pointing to something which can be typecast to anything to access that particular element. It is actually, when it is pointing at, it doesn't know what is the type of the thing it is pointing at, what is the type of the variable. Now, what about the size of void star? What is the size of void star? Because a void star is a pointer, so you need a space in the memory to store this void star. Suppose if I declare a void star VP, a pointer, and then VP is equal to something ampersand IP, I am saying, or ampersand I, then you need a placeholder for storing the address in the memory where the variable VP is pointing, VP is located. So that is same as any pointers. The size of void star or size of integer star or size of character star, they are all same. So if my machine is a 32-bit machine, then the pointer's size of will be 4 bytes. Okay. Okay, that is about void star. Now let us come to the code now. What are we having? We have a structure which are having only pointers. These are all elements. So let me show you what I am trying to do. We have initialized it. I took the address of all these variables and converted it into a void star and stored it in the structure. Now, one thing all of you must be knowing, when you do a typecast, that content is not modified, especially when the pointers are getting exchanged. When you say int star to foul star, float star to char star, the content doesn't change at all. The same address is coming here. Only thing is the compiler does not crypt, and it understands that the address where it is, what it is now pointing at, is an integer or a character. It understands from the type of what you are assigning it. So the void star the integer star and character star and float star, these are all the pointers are all different types. They're all converted into void star and gone there. Now what happens? We are doing a memcopy, stores to destination. So what is that? S2 is having the addresses. And then I am just copying the addresses which I stored in the S2 array into S1 array. That means the void star pointers are now sitting in the right place now because I have ordered them in the same way. So when the structure, normally the C orders in the same way in the memory. So that's why you are able to copy to all the void stars, which are actually pointers to integer and characters and floating point. And when you do a structure copy, they're all sitting in the right place. And all these pointers are of the same size. That's why you don't have any problem. When you say size of S1, S2, S3, they'll all be same. So we have now got the addresses of those integers and characters and floating point now with this memcopy. After that memcopy, I think it is very standard. You are S2, V1. Actually, I am using S2. After doing a copy, I am not using S1 actually. I should have used S1. No, I am using S1 here to confuse you. So I used S2 to do the updation, and then using S1, I'm accessing it. S1 is also the same addresses, so all of you got it right. Okay. I hope the explanation is enough. Any questions, guys, from anyone? Okay. Any questions? What do you want? You want 10 minutes break and then continue, or leave you 10 minutes early? Whatever works for you, I am fine. Leave early. Okay. So what we will do, we will stop, a hard stop, break. See, I have to honor the break, because if I don't, they will break themselves. So break for 10 minutes. We will meet at 8:23, 7:23. Yeah, 7:23. 7:23 p.m. guys. Okay, take a break. Maybe I will flash the next question and then we can leave it. Those who want to spend time, we can do it. Very small question. Oh, it is big. So let me only concentrate on 4. Okay, correct. This is good. Before I go into 4, shall we start? I think we are already okay. Okay. So I think who asked me? Okay, Debashish. Okay. See, let me explain this portion first. Where are we? What is exactly your question? Typecasting. Okay. See, suppose, let me show you what is being done here. This particular typecast. Okay. S2 dot V1 equal to void star ampersand S3 dot I. Now, what are we trying to do here? We are getting the address of the integer which is stored in the S3 structure. Okay. Now, whatever address we got is some value. Okay. Some hardcode address value. But just because I have dereferenced an integer variable, it has a type associated with that, which is an int star. That means it's a pointer pointing at an integer object. Okay. We are all an integer value. So effectively, this is an address, but where it is pointing is an integer value. Now, why is it required? Whenever you have an address, it is not enough if you know that it is an address, but you should also know whether it is what type of address it is. Now, the reason is you may have an address which is another address. Suppose I have another address 1, this is address 2. It is pointing at a character, suppose some character A. Now, when I access, the address could be any address. It could be odd aligned or even aligned in the memory. So there are so many bytes in the memory. Let us assume that it's a 4 byte, and then different bytes are there. Now this address happens to be some 100, suppose. Then if you know that the address is pointing at integer, then you will know that, okay, starting from 100, how far I should read to get the value. Okay. Now, suppose if I know that int is a 4-byte value in this current machine that I am running on, then 100, 101, 102, 103 are the locations I should access in the memory to get the complete value. I have only one address, but I read 4 bytes starting from that address. Whereas if I have another address 104 here, and if it happens to be a character star, okay, then I will not go on reading it. I will read only 1 byte and then say, okay, this character star points to one character, which is a 1 byte. So that is what I said, scalar value. Now, this when I have this address and then I typecast it to white star, what I am doing now is that the same address value is copied into this variable, but now I am doing this because compiler will crib if I don't do this, because I am assigning an integer pointer to a void star pointer, because v1 I have declared it as a void star, right? If you see that v1 is of this structure is a void star. So when I am assigning into v1, I should make sure that compiler is happy and I also know what I am doing. So I am doing it. But the value what I pass, there is no change to that, because it is the same pointer, whether the pointer is an integer type or character type or whatever, the 100 doesn't change at all. Now I can call this 100, whatever the address, as a character star. Then I will assume that whatever is the content in this memory is a character value, some character ASCII value. So I will read only 1 byte and then process it. So you are free to typecast an address to any type you want. I can even call it as a structure, pointed to a structure. Then it will assume that all the bytes following this, suppose structure is having some 100 byte is the size, then starting from 100 locations are considered to be a structure of type something. That is how the pointers are handled, and the typecast is just to say the compiler is happy, and we also know what type of pointer we are manipulating it. And then I hope the scalar value what I explained plus plus you are clear, the scalar value, which will be based on the type of the variable. It will be incremented by that much time. If it is an integer, maybe 4 byte or 8 bytes. If it is a short, it will be incremented by 2 bytes. The address will be incremented when you say plus plus based on the scalar value of the type it is pointing at. That's what is called scalar value. You got it? Okay. Can you confirm, Debashish? Deboshish, I think I should say in Bengali. Okay. I lost you guys or what? Oh. Okay, okay. I suddenly felt. Okay, can I go ahead? Okay, if you use what is the question? If you use white star typecasting in whole question, the output is same. Okay, if you use white star typecasting in whole question, then I didn't understand the question here. Can you come online, Anand?
Hello.
Yeah.
So basically, what Anand wants to say is, if everywhere we are using void, then the output should be same. Yeah, because even I think because we are not doing any plus addition or subtraction of pointers.
Yeah, yeah.
So yeah, so output should be same. If we are adding something to the pointer, then the type of the pointer will come into play, because whatever we are adding, we have to multiply it by the type of the pointer and then we have to add it. But here that is not the case, so output should be same.
Yes, you are right.
Yeah.
Okay, got it. I hope Anand also is clear. Okay. So where are we? 4, I think it is very clear. You guys got it. Nothing much. By now, yeah, I plus A. What is the time going? Okay, I'm just keep incrementing the value of ASCII and filling it up and then printing it. Now, why is it printing? Percentage C S I am printing. So how is it printing? Because I have declared this as a static array. If you are not put static here, there will be a problem. Okay, let me explain that. Let us try to run that. Question 4. Okay, first question 4 we'll enable and run it, and then we will remove static and see what does it do. Okay. Rebuild. Okay. So A, B, C, D, E, we got it. No problem. Now, let me do something funny. Let us, okay. Let me not, otherwise you will. Now, what do you guys think will happen? I want to answer from you rather than me telling. Can you guess what will happen here? I have not declared the C array as character. Okay. When will it stop?
Sir, is my voice audible?
Yeah, yeah.
Yeah. So what will happen is that this will go on till the 16th element, and it will keep on printing the garbage values.
Okay. Why that? Where is that 16 coming now? Why should it be
Okay.
bothered?
It will not be 16. It will not be 16.
Ah, yes.
My
You are
bad.
right.
Yeah.
So it will not know that it is accessing a 16 or 160 or 1100. It doesn't know. Okay. So when will it stop? Okay, stack is correct. When will it stop? You said it is going on, goes on, but it will stop somewhere, right? Should it stop or will it not stop at all? I explained it in the previous question explanation. See, percentage, yes. Eventually stop when? Very good. At null. See, I will explain. Now, this is actually interesting point has come up now. See, what is happening here? I have declared it as this variable C array. I said 16, okay? That means what? When the compiler or the tool, when it is running, actually while the program runs and question 4 was entered, question 4 function was entered, it allocates stack frame, I said, okay? Stack frame. Stack frame is nothing but what? Some memory, right? Some memory in the stack area. It is not that if it allocates stack frame, there is nothing here. It is not like something will jump out. There is some memory, most probably, okay? And it could be limited by some page, okay? Whatever page it is. Suppose page is, it is very, cannot guess it anything. Let me tell you, page size is suppose some 4 kilobytes. Then page boundary is where the stack has to now stop accessing it, okay? What I'm saying is, suppose not stack is somewhere in a page, and it is in the memory, and it is in a particular page. So page has got a limit. So now you don't know where this particular stack frame is actually in the page. It could be in the top of the page, or it could be in the bottom of the page. We don't know. But it can go on accessing the memory without any problem till it finds the page frame limit. Okay, page frame is the limit where is the process, this process, whatever this process is having, it has access to only this page frame. There may be next page frame, which is some other process is accessing it and it is using it. So OS will catch it when this pointer keeps on accessing the memory, but it doesn't find the null. Assume that there is no 00 encountered during the time. It will go on till it ends with the page frame limit. Beyond that, if it tries to access it, it doesn't belong. That when MMU is translating it to the physical memory, that MMU itself will catch it. Okay, MMU will know that your page frame limit is something, so it will catch there. Otherwise, MMU means OS. OS will be taking control, and then it will give segmentation fault. Okay, and that is also limited to only this process. This process will be terminated and it will stop. It will not disturb the OS or anything. Luckily, we are not writing anything into it, and even if you try to write it, it will not allow you to write into some other page, because the MMU will stop you from accessing some other memory. So it is not that always segmentation fault has to come. It could be that 0 is encountered, null is encountered, then it will stop. But till then, it will, whatever characters, it will not be printable characters, all of them, what you get. So it will be printing some junk because of that. So let me rebuild now with this. And then, did I rebuild fully? Yes. Yeah. Okay. Now run it. It is stopping at AB itself, because it could be the possible that we are having 0 only. Okay. Now, how do I make it happen? We have to write some junk into it. Okay. Otherwise, we will not be able to recreate it. It is very difficult to recreate it, but it is assured to stop when you have a static. But here, okay, what happens when you declare as a character array in a local stack memory? Let me explain. What happens when you are allocate a character array or any array, if you want to array of some 100 bytes in stack, okay, in stack array. Now what happens is 100 bytes or 100 into 4 bytes, because size of integer is integer, suppose, is allocated, 400 bytes are allocated in the stack. When I say allocated, means the stack pointer is advanced by 100 bytes, so that this area is used by this function, whatever function it entered with. So you have the 100 bytes in your control, but what is inside is not done, because we are not initialized it. It don't know, the software or the tool does not take care of initializing it. It just gets you a block of 100 bytes in the stack and gives you that it is the array address. So that's how it happens. And then somebody said that 16 it will stop. It will not stop at 16, because it doesn't even know what is the size of this character array is, because it's not like an object in Python or in Java where it will know the limit of the size. Okay, size of that object. Okay, that's I hope this is clear. You can try running it with the different things. You can play around and try to recreate issues. So let me go back the old code so that maybe I leave it commented also, so that you remember what I tried. Okay. Shall we see one more question before we break? Okay. Unless you have some other doubts, we can go to next question. Okay. So far, so good. Now I'll show it in PDF because it is visible. So let us see. C array is static array. It is somewhere in the data memory. Now we have already filled it with a B, C, D, E, F, G, H, I. We have already filled it. 0, 1, 2, 3, 4, 5, 6, 7, 8, less than 9. So we have filled it. Now null will be there because it is a static array. Because everything is 0, 0, 0. So we have overwritten till this point 8. So 9 will be having 0. So it will be considered as a null for printing. So it will not print beyond I. So that is taken care of. All of you are getting it correct. Now manipulation. FP is equal to float star C array. Now what happens? This will give this address, whatever is the address, starting address, it will consider to be a floating point address. Though it is actually a character array, it doesn't matter. As I explained, this address has gone in as a floating point address. So as far as the program is concerned, it thinks that the C array is having floating point values. That means 4 bytes of one float value, maybe another 4 bytes of float value, because float is always size of 4 bytes. Fine. Now FP is having this address. Now when I say FP plus plus, what is happening? That's where I think you guys are going wrong. See, when I say FP pointer, it is accessing wherever the C array is starting. But when it has to access the next floating point value, FP plus plus is, it has to, it's like a floating point array. Suppose if I have a floating point array, then it will be incrementing by 4 bytes. So whatever is the address, it will be incremented by 4. Plus 4 will be done. So in terms of this, it will be this address. That means it will be accessing, starting from this, it will assume that some floating point value is there. This is some floating point value, which we are not dereferencing it, but this is the address, the E, wherever E is there, that is the address, that byte, particular byte, our FP is pointing at. This FP is now, after incrementing, it is pointing there. Now, we are converting that FP to character pointer. Now we are saying that this is no longer a FP pointer, it's a character pointer, okay? CP. Now, this is also address where CP is also pointing. CP is now assuming it is pointing this, it can access character by character, because the same address from there, it will be accessing byte by byte. Now, after having written that, what I'm doing, star CP. That means wherever the CP is pointing, I want to put a character there. That means I am interested in replacing this character E with some other character. I need to replace it with some other character. What character I am replacing it with? That we have to see. First, FP. FP was, where is it pointing? FP was also pointing here. I do FP plus 1. It is same as FP plus plus. Don't think that it will be incrementing it by 1, because it's a floating point pointer. It will increment by 4. So it will increment, when I say FP plus 1, it is same as FP plus plus. So it will increment by 4. So it will now, FP will point to where the I is stored. Okay, 4. E 4, 5, 6, 7. So 8. Now FP is pointing here. FP plus 1 will bring the FP here. I convert that address also to character star. Now this pointer is also made as a character star. Okay, I do that. And that address value is just, now I'm going to consider it to be a character star. And then I do a dereferencing star. Then I am accessing a character stored in that address, which is I. Then where am I writing? I am writing into CP, wherever it is pointing. CP is not changed. So E is replaced with I. So what you get will be A, B, C, D, I, F, G, H, I. Some of you, I don't know why you thought of replacing this or replacing this, because the main problem is FP incrementing by FP plus plus or FP plus 1, both are same. It will be 4, because any arithmetic, pointer arithmetic with the pointer is done considering the scalar value of the pointer. So FP happens to be a floating point. So plus 1, if I do, it will not do just a, this arithmetic is not like adding 1 to the floating point address. It is adding 4 to the floating point address where the FP is pointing at. If you have that clarity, you will know where it is going. Okay. So now let us just run it and then we will stop the class with the 5th question. Okay. You can ask me any questions. I will open the chat. Now I hope you are clear. Okay. Same code is there, so you don't have to verify. I hope you can see A, B, C, D, I, F, G, H, I. Okay. If you want to really, I think this example itself is enough for you to get a clarity on what is happening underneath. But print some values and then you can start percentage P you can use to get the actual printer address value, and then you can get a better understanding. So what I will do, I will remove other questions and then I will only share this portion. Maybe we will cover these things in the next class. Whatever you guys are okay with that, because I don't want you to run it, because all the fun will be lost if you run the code. I want you to think before running the code. So I can do that only when I don't share it now. Sorry, I am so... Okay. Is it clear so far? Play around with the program that I give you. You will become good embedded engineers. Okay, great. Fantastic. Okay. Thank you. Have a nice day. Bye-bye.